Good morning, students. So, subject electronics devices and circuits. Chapter number 4 oscillators. We have started in our last session, and from that chapter we have covered following points. So, oscillators. What is mean by oscillators? Then oscillators versus amplifier. Oscillator versus alternator. Then what is sinusoidal oscillators? Then what are the nature of sinusoidal oscillation? Then we have seen the Barkhausen criteria. So Barkhausen criteria says that the product gain of amplifier gain into feedback factor gain is equal to 1. Then we have seen that the types of oscillator. So phase shift oscillator, band pitch oscillator, tuners oscillator circuits. In that we have seen the two oscillator, that Colpitts oscillator and Hartley oscillator, and crystal oscillator and unit junction oscillator is removed. So RC phase shift oscillator is nothing but the in feedback circuitry, resistors and capacitors are used. Then Wien bridge oscillator. In that Wien bridge oscillator, 4 arms are used, and in that also the capacitor and resistor combinations are used. Then we have seen that the tuner oscillator circuits. So in that Colpitts oscillator, in feedback, 2 capacitor parallel with 1 inductor, and in Hartley tuner oscillator, 2 inductor with parallel with the capacitor we have seen. So next is the crystal oscillators. Okay. So the crystal appears to the rest of the circuit as a resonance circuit. Okay. So the crystal appears to the rest of the circuit as a resonance circuit. Since previously we have seen there is in the feedback circuitry resistor capacitor combination, or one can use that the resonance circuit to produce that the different frequency at the output side. So here the name itself indicates that it is nothing but the crystal oscillator. So crystal is appear in the feedback circuitry of the oscillator. So here that figure shows that this is nothing but the one crystal, and here it will replace this RLC resonance circuitry. So the same thing is here, only that the device is changed. Means previously there is the RLC circuit combination is used in the feedback circuitry, but here we are going to use the crystal as a component in a feedback circuitry. So let us see the crystal resonant frequency. Okay. So the crystal has 2 resonant frequencies. So which are they? Series resonant and parallel resonant. So RLC determines the resonant frequency. The crystal has a low impedance. Okay. The RLC determines the resonant frequency. The crystal has a low impedance. While in parallel resonance, that is R1 and Cm determine the resonant frequency, the crystal has high impedance. Okay, so what is the basic difference between the two resonant frequencies of the crystal? One is the series resonance and another is the parallel resonance. Series resonance, that is a resistor, inductor, capacitor determines the resonance frequency, but this type of the crystal has low impedance. Parallel resonance, in that resistor and inductor are in series and with the parallel with the capacitor, so it will determine the resonance frequency, but for this crystal has high impedance. So the series and parallel resonance frequencies are very close within 1% of each other. Okay, so the series and parallel resonant frequencies are very close within 1% of each other. So here, impedance versus series resonant and anti-resonant is shown. Here, F1 and F22 frequencies are shown. So see here, for the series resonance, if at the zero frequency there is a high impedance, but whenever the oscillation frequency increases, the impedance is going to the impedance is decreases. While in that the parallel resistance, when it will generate the high frequency, at that time the impedance goes on increasing. So that is the difference between series resonant and parallel resonant. Okay, so crystal resonant having two resonant frequency, series resonant frequency and parallel resonant frequency. So what is the difference? The circuit arrangement for the series resistance, that resistance, inductor and capacitor is in a series which having the low impedance, and in parallel resonance the resistor, inductor and capacitor, they are in parallel to each other and the crystal has a high impedance. So if we see the frequencies for the series and parallel resonance, so it is very close within 1% of the each other. So let us see the series resonant crystal oscillator. So here that the FET is used while there is a one crystal is used in the feedback part of the oscillator. So here radio frequency chalk is used, okay, and output is taken from that the drain of that FET. This is nothing but the gate resistance for that the grounded. So here crystal is coupled with that the coupling capacitor at the okay, from that the output, that the whatever the signal is coupled through this crystal to that the input of that FET. So this is the circuit arrangement of that the FET crystal oscillator. Okay, so we have seen here crystal oscillator. So crystal is nothing but the replacement of this RLC circuit. Then crystal resonant frequency having series as well as the parallel resonance. So series resonant crystal is shown in here, that is FET crystal oscillator. So next is the unijunction oscillator. Unijunction oscillator. So here there is a UJT is used instead of that the FET. So it is having one emitter terminal and two base terminals. So across these two base terminals we are going to take the output. R1 and R2, these are the resistors which is used in series with this connection. This RT should provide that the threshold voltage for the VE, and this is nothing but that the capacitor. Then frequency of oscillation for unijunction oscillator is given by F0 is equal to 1 upon RT log in of 1 divided by 1 minus eta. So where this eta is equal to 0.4 to 0.6 and it is range rating of the unijunction transistor. Okay. So next, that is oscillator is nothing but the unijunction oscillator. So unijunction oscillator, that is UJT, which is having three terminals like the FET, but the terminal lengths are somehow different. So emitter, and there are two base terminals. So across that two base terminals we are going to take the output, and input is applied to the emitter. So this is nothing but the circuit arrangement for the UJT. Then let us see the unijunction oscillator waveform. The unijunction oscillator or relaxation oscillators produces the sawtooth wave. It is here sawtooth wave is produced. So simultaneously there is a B1 and B2 having the polarity. So B2 when B2 is positive, the B1 is positive, then VB2 is the negative. So due to that, the capacitor is going to be charged. So capacitor is going to be charged and discharged. So due to that the P2 it is going to be discharged. From this period again it is due to this charge. So see here when this unity the B2 will be act, it will provide the positive cycle. When that the B1 side is activated, there is a negative cycle closer. So here once again we have seen that if there is a two stage, then if there is a two stage, at the second stage it will provide the negative waveform. So let us see the UJT basic construction. So UJT is nothing but the unijunction transistor. Why it is known as the unijunction transistor? Because only one charge carriers are responsible to produce flow of current from that body. So that's why it is known as the unijunction transistor. So here emitter is there, aluminum rod is here. So intersection of this, the PN junction is formed. So this is nothing but the N-type high resistivity silicon slab. Then over that we want the two contacts. So ohmic base contact is generated. Then from one end B1 is taken out and from second B2 is taken out. So across the B1 and B2 we are going to take the output voltage. So unijunction transistor, that is UJT. Why it is known as the UJT? Because only one charge carriers are responsible to produce the current. So what is the construction of this? So the figure shows that the construction of that the UJT. So it is having the three terminals, emitter, base and base, that is B1 and B2. So at the emitter, aluminum rod is there and it will attach to that the N-type high sensitivity silicon slab. Then intersection of this there is a PN junction is formed. So this is the N-type high resistivity silicon slab. Then there are two ohmic base contacts are taken out. So one is known as the B1 and another is known as the B2. So across the B1 and B2 we are going to take the output voltage. So this is UJT transistor. So the UJT is also basically a switching device. So for that the UJT emitter, that is input current IE, and at the output side V1 and V2, and the output current is IB2. So even though the UJT is switching device, it works very differently from the SCR variety of devices. So see here the equivalent circuit indicates that the UJT is like the diode and a resistive voltage divider circuit. So the resistance exhibited by RB1 is variable. It is dependent on the result of current IB. So here IB shows this state, then RB1 and RB2, and the out is taken out for the process. So the equivalent circuit indicates that the UJT is like a diode and resistive voltage divider circuit. So thus resistance exhibits by RB1 is able, RB1 is variable. It depends on the value of current I. UJT is the switching device. It works very differently from the SCR variety of devices. So next is the UJT characteristics curve. So see here, a voltage is applied across the VJT, that is VBB, and the emitter input. Once VE reaches to the peak value, that is VP, once that the VE reaches to the peak value VP, that is peak point, the UJT begins to conduct. UJT begins to conduct. At the point where VE is equal to VP, at the point where VE is equal to VP, the current IE at minimum. This is threshold value of VE that puts UJT into conduction. This is threshold value of VE that puts the UJT into conduction. Once conducting IE increases and VE decreases, this phenomenon occurs because the internal resistance labeled RB1, in equivalent circuit decreases as UJT conducts more and more. So this is called as the negative resistance. So this is cutoff region, negative resistance region, where the IE increases but the VE drops off, and one point is here, that is valid point. Okay, so this is called as negative resistance. So we have covered crystal oscillator. In that crystal oscillator, series resonance and parallel resonance, how that the impedance low and high. After that, we have seen the series resonance crystal oscillator, then unijunction oscillators, then characteristics of UJT, that is UJT is also having cutoff region, negative resistance region and saturation region. So in this graph also, peak point where V is equal to Vp, and there is a valley point also. So here our oscillator chapter is finished. Okay, so we have seen that what is mean by oscillator, then Barkhausen criteria for oscillator, then the RC phase shift oscillator, universal circuit oscillator, bridge oscillator. Okay, so there are several different types of that oscillators. So oscillator is nothing but the circuitry which generates the various waveforms, sorry, various frequency waveform at the output side. Thank you.